Hey everyone, in today's video we are going to do something a bit crazy. We're going to modify a super budget friendly PC to run a large language model, something typically reserved for high-end machines. I bought this little PC for just 35 euros. It's over 10 years old and it's got an Intel 6th generation i3 processor with 8 gigabytes of RAM. Not exactly a powerhouse, right? But that's where the fun begins. We're going to give this old machine a serious upgrade and I'll walk you through every step of the process. Here it is. Looks pretty basic, doesn't it? It's got an old school i3, nothing that screams performance by today's standards. But here's the plan. We're going to modify it to handle something much more demanding. Running a large language model or LLM, and we're going to do it on a tight budget. First things first, we need more power. This little machine has a basic power supply, so we're going to replace it with a server grade PSU, something more powerful that can handle the load of additional components, especially a GPU. Speaking of GPUs, that's the second upgrade. We're going to add an affordable but solid graphics card, the AMD Vega 56. It's not top of the line by any means, but it's a great budget option for tasks like machine learning, and it's going to make a huge difference in performance. Alright, now that we've talked about the basic components, let's dive a bit deeper into the modifications we're going to make to the power supply of this Prodesk 400 G4. This PC has a non-standard power supply, which means we can't just plug in a regular ATX PSU. However, there's one big upside to this. This system only requires a 12-volt input, so we don't have to worry about a complex multi-voltage setup. Now, the power connector has two distinct types of connectors. There's the standard one, and then there's another one which might look confusing at first, but it's actually quite simple once you break it down. There are two pairs of pins, one for the 12 volts and the other for ground or the mesh line. We are only concerned with those two pairs. There's also a green wire in the connector, which is the energy saving signal. We're not going to bother with that as it's not necessary for our purposes. The power supply will run just fine without it. Now let's talk about the new power supply we're going to use. This is a PL30 server PSU, which comes from an HP server. It's a beast of a power supply delivering 1200 watts, which is way more than we'll ever need for this project. But the good news is it only costs around 20 euros on the second-hand market. Definitely a bargain when you think about the power we're getting. One thing to note about server PSUs is that they often need a small trick to turn on. You can't just plug it in and expect it to fire up. But don't worry, it's simple. All we need to do is add a small resistor. This will trick the PSU into thinking the system is ready to go. I'll leave a link in the description that explains this trick in more detail. Next up, we're going to solder the wires from our new PSU to the connectors we need. The connectors we are using are actually salvaged from old PCs, so we're reusing some parts to keep the cost low. For the motherboard, we're using the standard 4-pin connector. And for the GPU, we'll need the 8-pin connector to supply power to the Vega 56. As you can see here, I'm carefully soldering the wires to the connectors. This step requires some precision, so make sure to take your time and double check your connections. We want a solid, secure connection to make sure everything runs smoothly when we power up the system. Alright, we're finally at the exciting part. After all the hard work, it's time to power up this modified system. Let's see how everything comes together. Everything powers up perfectly. It's a great feeling to see this old budget PC running smoothly. But there's just one thing left to do. Install the GPU. So, here's the catch. The case is way too small to fit the Vega 56 GPU. We've got a bit of a space issue, but don't worry, we've got a solution for that. We're going to use a riser cable to extend the GPU outside the case. This riser cable is 20 centimeters long, which is a little longer than ideal, but it'll do the job for now. We'll just plug the GPU into the end of the riser and secure everything. Don't forget to connect the power cables to the GPU. Very important. So now the GPU is connected to the riser and we've got everything powered up. Yes, it looks a bit messy, but it works. The GPU is now hanging out the side of the case. Later on, we could make a more permanent solution, maybe even drill a hole in the case to make things look cleaner and more visually appealing. Now with the GPU installed, everything starts up just fine. We're ready to get into Linux and test things out. Now we boot into Linux and everything seems to be running smoothly. Next, we need to install the necessary drivers to get the GPU working properly. We've got the AMD GPU drivers, the ROCm software for compute tasks, and Ollama, which is the software we're using to run inference engines for large language models, LLMs, and vision models. Once the drivers are installed, we're good to go. We fire up some small LLMs like Phi3 and Llama 8b, and the results are awesome. We're getting dozens of tokens per second. Pretty impressive for a budget build. We can also run vision models like Lava 7b with no issues. Overall, the system is stable and performing surprisingly well for its age and cost. We've basically turned this low budget PC into a small server that we can access using Ollama's API, which is compatible with OpenAI's API. This gives us full control over our LLM, allowing us to adjust settings and avoid potential privacy concerns that come with using cloud-based services. So, to sum it up, we've taken an old budget PC, upgraded the power supply, installed a Vega 56 GPU with a riser cable, and set it up to run small LLMs and vision models. The results are fantastic, and it's a great way to have your own AI server on a budget, with full control over your data and privacy. Thanks for watching, and stay tuned for more videos where we'll continue improving this setup. Don't forget to like, subscribe, and check the description for links to all the tools and guides we've used in this project.